Okay, so this is the second part of or second installment of our discussion for hypothesis testing, and we'll be covering z-test for one sample mean. Okay, so again, this is a quantitative discussion, so I do encourage you to please have your scientific calculators with you. Okay, so for the formula for z-test for one sample mean, we have z is equals to your sample mean less your population mean multiplied by the square root of your sample size divided by your population standard deviation, okay, indicated by your sigma. And take note that we will use z-test if the population standard deviation is known. That's why we have it here, the variable, and your sample size is large. Okay, so meaning n is greater than or equal to 30. Okay, so uh, again, this is your formula. It's just a straight formula. You just um, place the given on the formula, and then you can already compute for the value. Okay, so let's have an example. Or before that, um, these items are very essential in terms of your hypothesis testing using z-test. So this table is considered to be your table for critical values for z-test, in which um, based on your level of significance and level of test, okay, or depends on your hypothesis whether it's directional or non-directional, you'll be having or you will be identifying the tabular value. Okay, so to simply put, these six values are considered to be your tabular values. Okay, but it will be dependent on your level of significance, and it will also be dependent on the type of test that you will be using. Okay, so later we will be um, applying, okay, the concept of your critical values towards our quantitative part. And let's have an illustrative example. So in here, we are being asked whether an average box of brand new full cream milk contains more than 350 grams of milk. Okay, so meaning um, on average, or our expectation is that um, for a box of brand new full cream milk, it should contain, okay, 350 grams of milk. Okay, but we are trying to state now, or we are trying to test whether, okay, an average box of brand new full cream milk contains more than 350 grams of milk. Okay, so what's our what's our data for us to check it? So let's say you have used a random sample of 30 boxes in which you have computed that the sample mean of those 30 boxes is 350 grams. Okay, so uh, and let's say the company, okay, brand new company, has specified that the standard deviation is 10 grams, and let's say we'll be using 5% level of significance. So with all of the given, our problem here is that we are trying to establish now, okay, whether an average box of brand new full cream milk contains more than the expected, which is 350 grams of milk. Okay, why? Because again, based on the sample, the average is more than what's expected. Okay, so in here, um, for us to determine whether there's a significant difference between your sample and your population, we will go back to the 7 steps. Okay, so we will first formulate our null and alternative hypothesis. Second, we will now set the level of significance. Third, we will determine the appropriate test statistic to be used. So based on the title itself, for all of these examples, we'll be using z-test for one sample mean. Okay, and then next step is for us to determine the critical value or your tabular value, in which it will be coming from the table which was shown to you a while back. Okay, the critical values of z-test. And then number 5, we will compute for the value using the given, okay, from this data or from this case, and using the formula which was presented to you a while back. And next, you will compare your critical value or your tabular value and your computed value. Okay, and then you will state your conclusion. So if we will have a refresher of the introduction of hypothesis testing, your conclusion will be what type of hypothesis are you going to accept and what hypothesis are you going to reject, okay, between these two, okay, your null and alternative hypothesis. And then step 7, you will now interpret your results. So let's start. So going now to your first step, we will formulate the null and alternative hypothesis, correct? And in here, uh, for us to formulate our null and alternative hypothesis, we need to go back to the problem and we need to identify the question. Okay, so what's the question here? This one. We are trying to conduct a study, or we are trying to test whether brand new full cream milk contains more than 350 grams of milk. Okay, so what will be our hypothesis then? So null hypothesis, if you go back to our discussion, um, this is the type of hypothesis in which it states objectivity or neutrality. Okay, so to simply put, if we will apply that to our statement, then we'll be having this. So an average box of brand new full cream milk does not contain more than 350 grams of milk. Okay, so meaning, okay, it's actually equal to 350 grams of milk. Okay, so to simply put, um, what is expected amount of milk on a or an on an average box of brand new full cream milk is 350. That's why for our null hypothesis, uh, we will state that the content of an average box of brand new full cream milk is still 350. Okay, so meaning it does not contain more than 350. Okay, because that's the expectation. Okay, and for our alternative hypothesis, so we will now contradict this statement. So again, we are trying to assess whether or not brand new full cream milk contains more than 350 grams of milk. So null hypothesis, we are stating that it does not contain more than 350 grams of milk. So it's objective. Okay, it's neutral in nature. That statement is neutral in nature. So if we will contradict it, then we'll be having our research hypothesis, our alternative hypothesis, in which we will now state that an average box of brand new full cream milk contains more than. Okay, so this statement states that does not contain more than 350 grams, but this one contradicts it. So we are now trying to state that it contains more than 350 grams of milk. Okay, so with that, you now have your null and alternative hypothesis. Okay, or if you want, you can actually identify the population and sample, okay, from your data, and then you can use that for you to create your alternative and your null hypothesis. So let's go back here. It states here that the average box of brand new full cream milk has a content of 350 grams of milk. So meaning that's the characteristics of your population. Okay, but based on our sample, it has a mean, okay, an average of 357. So this is your sample. Okay, so if you will formulate your null hypothesis, we can simply state that there is no difference between the population and sample mean. Okay, so in short, that's it already expresses neutrality, or there's no difference between our population and our sample. Okay, and then we can also state, let's say, an alternative hypothesis basing from that null hypothesis in a manner that, let's say, it's, or we can state that there is a difference or significant difference between the content or average uh, content of the population and the average content of the sample. Okay, so you can use that if you want. But in here, what we had done is for us to look for the problem, and then we have converted the problem into your null and alternative hypothesis. So step 2, we will now set the level of significance. Technically, for the level of significance, it's given. It's 5%. Okay, so we'll be having alpha level of 0.05. Okay, and next, we will determine the appropriate test statistics to be used. So here are our parameters. Population standard deviation is known. Okay, so it's given here. So it states that the company has specified that the standard deviation is 10 grams. So what does that mean? All of the boxes of brand new full cream milk that was manufactured has a standard deviation of 10 grams. Okay, so it covers all of the boxes, not only the 30 boxes that we have used as or for the sample. Okay, so population standard deviation is known. Our sample size is large. It's greater than or equal to 30, in which it's actually equal to 30. Okay, and uh, it's a one sample, or from the given we only have one sample mean, so this one 357, because again this is your population mean. Okay, this is the population mean, this is expected, or this is the characteristic expected from all of the boxes, but based from the 30 boxes that we have used as our sample size, this is our sample mean. Okay, so we have one sample mean. Therefore, we'll be using z-test for one sample mean. So technically, it's given on the title of this presentation. And we need to determine first whether we are going to use directional or one-tail test or two-tail test. So in here, if you will go back to our alternative hypothesis, it states that an average box of brand new full cream milk contains more than. So that's a comparative word, correct? It clearly states the comparison between your population and your sample. Okay, so it contains more than 350 grams of milk. Therefore, this hypothesis is considered to be a directional hypothesis. Okay, in short, because it's a directional hypothesis, we will now use one-tailed test. Okay, so please take note, one-tailed test for one sample mean of z-test. So number 4, we will now determine the critical value or the tabular value. So this is your table of your critical values or tabular values for z-test. Okay, as stated in our previous slide. So we need to identify the variables or the given. So it states here that we'll be using 5% significance level. So level of significance is 0.05. So meaning our critical value is found on this column, the 0.05 column. Okay, so between these two um, values, tabular values, which value are we going to use now? Okay, so that's where your uh, type of test would come in. So we have stated that our alternative hypothesis is a directional hypothesis. Therefore, we'll be using one-tailed test. Okay, one-tailed test. So at significance level of 5% and using one-tailed test, our tabular value will now be your 1.645. Okay, so please take note that for tabular value and your computed value for steps 4 and 5, you need to get the absolute values. Okay, so you disregard the negative sign. You treat all of the values as positive. Okay, you treat all of the values as positive. That's why we are using 1.645 here. Okay, so that's for our tabular value. Let's move on to step 5. We will now compute, okay, using the statistical test. So we are going to use again the formula for z-test for one sample mean, in which we will just um, substitute the given to our formula. So we have here sample mean. What is our sample mean? It's here, 357. It states that that's your sample mean. Okay, less your population mean. What is your population mean? This one, 350 grams of milk. Okay, so that's the expectation as to the content of all of the boxes. Okay, the average content of all of the boxes. And you have n, so that's your sample size in which you have 30 boxes, or the number of items found on your sample. That's your n. And your standard deviation, so it's given here, population standard deviation, which is 10 grams. Okay, so if you will substitute those figures, we'll be having 357 minus 350 multiplied by the square root of 30 divided by 10. Okay, so if we will simplify, we will arrive at an answer which is 3.83. Okay, so that's our computed value. So step 6, we will now compare computed value coming from step 5 and the tabular value coming from step 4. Okay, so in here, okay, so we have computed value which is 3.83 coming from step 5, and then tabular value of 1.645. Okay, so there we will now compare. So based from our data, our computed value is higher than, okay, our tabular value, which means we will reject our null hypothesis and we will accept our alternative hypothesis. Okay, I repeat, um, if you will go back to the guidelines presented to you in the introductory part of this discussion, if your computed value is higher than your tabular value, you will reject null hypothesis, meaning uh, it is significant. Okay, the difference is significant. But if your computed value is less than your tabular value, it states that the difference is insignificant. Okay, that's why you will be accepting uh, your null hypothesis in that case. Okay, but in here again, computed value is higher than tabular value, so we will accept alternative hypothesis, and then we will reject our null hypothesis. So as a result, for the interpretation, Okay, you will just copy the hypothesis that you will be accepting. So in here, we will be accepting your alternative hypothesis. So our interpretation is that an average box of brand new full cream milk contains more than 350 grams of milk. Okay, so that's already our interpretation. So let's have another example. So we have a random sample of 50 students from the school uh, was taken and was found out to have average score of 79. So based on prior test results, okay, of a certain culinary examination, the population mean, okay, has been found out to be 80. So this is the score of the sample, okay? This is the score of the population, okay? And the standard deviation of the population is 4. So we will now try to check whether or not there is a significant difference between the mean score of the sample, so this one, and the population. Okay, and we'll be using a significant level of 1%. So here, again, we'll be following the 7 steps. So please take note that for steps 4 and 5, your values will be, or you will be using the absolute values, okay, absolute form of the values. And then for number 7, you will interpret the results. So let's start. First step is for us to formulate our null and alternative hypothesis. So if we will go back to the previous slides, um, one way for you to formulate your null and alternative hypothesis is for you to identify the problem. So the problem here is this one. We are trying to check whether or not there's a significant difference between the score of the sample and population. Okay, so from there, you will now formulate your hypothesis basing from the problem. So what will be our null hypothesis? Here, there is no significant difference between your population and sample scores. Okay, and then if you will contradict that, you'll be having your alternative hypothesis. You will just convert the word no, to the article A. Okay, so there is a significant difference between the mean score of the sample and the population. Okay, so what's next? We will now determine the level of significance. Okay, our alpha level. So it states here that we'll be using 1%. So it's 0.01. Okay, it's 0.01. So what appropriate test or what statistical test are we going to use? So population standard deviation is known. It's found here. It states that the population has a mean of 80 and standard deviation of 4. Okay, so population standard deviation is known. Sample size is large, so it's greater than 30. So we have sample of 50 that's greater than 30. And we have one sample mean. Okay, so this is the mean of our sample. Okay, so we have 50 students, their average score is 79. Okay, so please take note that when we speak of mean, that's the average. Okay, so there. So we'll be using z-test for one sample mean, again as stated from the title of this discussion. And what type of test are we going to use? Is it one-tailed or two-tailed? Okay, so uh, I'll I'll let you check your alternative hypothesis. Okay, so this is our alternative hypothesis. What type of test are we going to use? Is it one-tailed or two-tailed? Okay, I'll give you 5 seconds for you to uh, check or determine what type of test are we going to use, and then later I will show you the answer. Okay, so um, what type of test are we going to use? Based from our alternative hypothesis, it states that there is a significant difference, but it does not state the direction of the difference. It does not say that sample mean is higher than population mean or population mean is higher than the sample mean. Therefore, I will be using a two-tailed test because our hypothesis is non-directional. Okay, so I hope that you have got the correct answer in terms of the type of test. So next, we will now determine our critical value. So here, um, what will be our critical value now? What type of test are we going to use? Two-tailed, okay, basing from the given. And then what's our alpha level? It's 0.01. Okay, so there. Level of significance is 0.01. We'll be using two-tailed test. Therefore, our critical or tabular value is 2.58. There, 2.58. Okay. So next, we will now compute for the value. So this is our formula. And then our sample mean. So if we'll go back to the problem, so the mean of these 50 students is 79. So there, their average score. And then population mean. So it states here that the population mean has been found out to be 80. So write 80. Okay. And then we have sample size of 50. So we have 50 students as our sample size. So square root of 50 divided by our standard deviation of 4. So 4. Therefore, our computed value is 1.7678. And if we will now compare, or proceeding to step 6, we will now compare your computed value and your tabular value. So which one is higher, computed or tabular? Okay. So what will be the conclusion now? If your tabular value is higher than computed value, are we going to accept your null hypothesis, or are we going to accept alternative hypothesis? Okay, so here's the answer. Computed value is less than your tabular value. Therefore, we will accept our null hypothesis and we will reject alternative hypothesis. Okay, therefore, for the interpretation, we will use our null hypothesis. So there is no significant difference between the mean score of the sample and the population. So meaning these 50 students actually has the same um, results or test results with that of your whole population, which has a mean of 80. Okay, so that's for our Z test for one sample mean.